Okay, so the three properties we just discovered, kite property number 2, there's one pair of opposite angles that are congruent. So we talked about, here's your kite, right? These angles here were congruent. We also had a long diagonal. One diagonal connecting the two was longer than the other. The long diagonal is the perpendicular bisector of the short diagonal. So remember, we had those diagonals crossed at 90 degrees, and it also cut this one into 2 equal pieces. We saw that because those triangles were equal. And then the long diagonal also bisects these angles. So these angles are not necessarily equal to each other, but however much they are, they're cut into equal pieces. That would be property number 4. Whoa, property number 4. All right, so let's apply these properties in example 1. We're supposed to be solving for angle x. So to me, the fastest way to solve this is we know that any quadrilateral, all the angles add up to 360 degrees. If you weren't sure about that, you could definitely n minus 2 times 180. So 4 sides minus 2 times 180, all the angles would add up to 360. And then we just figured out that these angles are congruent. And so if that's the case, you could take all the angles on the inside, which is 360 degrees, minus 70, minus 56, which gives us 234. And then we divide by 2. And each of those angles would be 117 degrees. Some people like to work this problem with dividing it into 2 congruent triangles and solving the top half and the bottom half. That works too. So whichever ways you prefer. On part B, we've got an 8 and a 5, and we're looking for the length of YZ here. These diagonals, since they cut each other into equal pieces, this is 5 here. I know my diagonals are also perpendicular. So essentially, I'm doing what? The Pythagorean theorem? This is not a triple, unfortunately. So 5 squared plus 8 squared equals c squared. So you've got 25 plus 64 gives us 89, which is prime. That does not break down, even if we wanted it to. And so c equals square root 89. Or x in this case, or I guess technically YZ. Oh, see, we got a bunch of things going on. So first of all of these angles in the middle we know are 90 since the diagonals are perpendicular. And then from there, you're basically just solving the different triangles. So let's start with the yellow triangle, 180 minus the 90 minus the 46 gives us 44 degrees for angle 10. Then you have, well, this is a congruent triangle over here, so automatically 5 would be 46 as well, and 8 would be 44 as well. Okay, so now let's go for this blue triangle here, in which case we have 180 minus the 90 minus the 34, and that gives us 56. And then again, if these triangles are congruent, which we discovered earlier that they were, then angle 6 would also be 34, and angle 7 would also be 56. So I'm going to let you try these two. So pause the video, give them a whirl, and I'll meet you on the other side. Okay, let's take a look. So I used a strategy of saying that all four of these angles I knew had to add up to 360. So I did 360 minus the 101 minus the 48, give me 211 degrees. And then from that, I divided the two congruent angles. So 211 divided by 2, each one was 105.5. And then for E, we have the yellow triangle on top. I knew the diagonals were perpendicular. So 180 degrees minus the 90 in the yellow triangle minus the 27 left me with 63 for angle 2. And then from there, once I knew angle 2, I knew the blue triangle on bottom was congruent, so angle 3 had to also be automatically 63 degrees. All right, I'll see you on the next video.